Okay, so in this video, we're going to talk just a little bit more about some kinds of chemical reactions, specifically precipitation reactions. So we'll talk a little bit more about precipitation reactions, solubility, and things like that. So let's get going. So where are we going with this? Why am I bringing up solubility? So we've just been kind of talking about chemical reactions in general, so we're going to narrow it down to one specific kind and build our skills from there. So in this chapter, we're going to look at specifically precipitation reactions with salt and water. So we actually did some of these chemical reactions in lab, in our lab 2, evidence of chemical reactions lab. Remember when the magical solid fell out of solution and it kind of looked like it was snowing in your reactions? We're actually going to get to learn the science behind what we're doing and why it works the way that it does now, which is kind of exciting. I like doing that. So we're going to talk a little bit more about other kinds of reactions throughout the semester, but these are relatively simple, and I kind of want to give you a chance to practice what we're doing and what we're talking about with some familiar ionic compounds before we get into the really hard stuff. So what is solubility and what does solubility look like? Well, So what does solubility look like? Well, to dissolve something, it's kind of broken into its individual parts when it's placed in another substance. So with ionic compounds, this means the individual ions. Remember, ionic compounds tend to look like this AgCl does down at the bottom of your screen, all these individual ions just hanging out together. So all those individual ions break apart when we put an ionic solid down into water. However, hypothetically, if we wanted to dissolve a molecular compound, we still get the individual molecules floating around. So if we're dissolving something, we're not breaking apart chemical bonds, covalent chemical bonds. We're only kind of breaking apart these interactions more, right? So these positives and negatives are just kind of hanging out together, so they'll break apart. However, remember, those molecular compounds have extremely strong covalent bonds, so they stay as their individual molecules. However, they split up and kind of hang out apart from each other in the water, therefore. So that's kind of the idea. So solubility is the ability of something to be dissolved in a particular liquid or gas. However, we're only going to talk about liquids for right now. We'll talk later about gas solubility and stuff like that. But solubility is the ability of something to be dissolved in a particular liquid or gas. The solvent is the liquid doing the dissolving, and the solute is the substance being dissolved. So you may hear me use those terms. You should become familiar with them. I will likely use them throughout the semester. So in a soluble salt, the ions are more attracted to the water molecules than they are to themselves, or than they are to each other. So they dissolve, or they separate from each other when they dissolve in the water. That's kind of why we get this scenario, like what NaCl looks like. All those little independent sodium ions, the little purple guys, and the chloride ions, the big old green guys there. So this is a solution of sodium chloride, and it is just these independent little ions, and they're basically surrounded by water molecules we can't see in this picture. So that's kind of how it works. In an insoluble salt, so something that is not able to be dissolved, the ions are more attracted to each other than they are the water for some reason, so they stay together and they do not dissolve. So in this case, silver chloride is an insoluble salt. It is not soluble. So therefore, if you drop a cube of AgCl in some water, it just sits there at the bottom and hangs out. It's just there. It does not dissolve into those independent ions. If two solutions with floating around ions in them are mixed together and they form an insoluble salt, that solid salt falls out of solution as a precipitate. So this was what we saw in our chemical reaction. So the idea is we took two salts that were soluble, we mixed them together, and we formed something that was insoluble and had a couple of other ions left in solution. So that's kind of what solubility is. So if we have an ionic solid, that means we break it into its individual ions if it can be dissolved in the liquid we're talking about. If it is not able to be dissolved, it is insoluble and it stays as like one unit, and we still consider it to be that solid in the water instead of its individual ions. So precipitations is what we call it when these insoluble solids fall out of solution when we mix two soluble aqueous salts together. So remember, an aqueous state just means that we have something dissolved in water. So if we have a salt that is soluble, it's going to be in the aqueous state because we have dissolved it into water. So a precipitate is the actual insoluble solid that is created by mixing those two soluble salt solutions. So there may be leftover ions that actually do not make the insoluble salt. They're still going to be suspended in the solution. They're still going to be just hanging around, floating around, being there, being ions. So that's kind of what we have pictured down here at the bottom. So we have potassium iodide with lead 2 nitrate, and we're going to mix them together.